Empirical probability is very similar to classical probability in that we are looking at the number of times an event occurs, but where it differs is we are now looking at the total number of times an experiment is performed. Now, you could think that that idea and this equation is very similar to the makeup of classical probability, and it is. The difference is we use empirical probability when we are talking about things like voter polls, grades, magazine polling, anything where we are talking about either a real life outcome or a specific event where we're using an experiment instead of a sample space. Okay, so here we're talking about the number of times that something might be happening versus, say, a total category. So I have a couple of examples that will try and help clear up the idea of empirical probability that we're going to look for. So here, you want to calculate your empirical probability. Again, you want to round your answers to the nearest million. So for this first one, it's talking about a news organization is asking selected voters that are exiting a polling place their age bracket. And so what they're getting at is they're trying to get at the, I guess, age groups that are voting in this particular election. And so we're looking at turnouts. And so what happens is instead of just giving numbers here, we actually have a data table. And you can see that my ages have been broken down into groups. So you have 17 to 29, 30 to 44, 45 to 64, 65 and older. And what they've done is they've put in here the number of people that said they were in that particular category. So when we're talking about the number of times experiments occurring, here, instead of like with rolling a dice where we're looking at each individual side, we are looking in this case at groups of data. So we're talking about larger amounts of data or larger probability sets. So here the first thing that you always want to do is you want to look at your total. So I want to know how many total people were answered. So to do that, you're going to add up all of these. So we're going to look at 9 plus 8 plus 32 plus 15 is going to give me a total of 64. And so that's what we're doing here. We are looking for your total number of voters by adding up what we have. Okay. Now, the first question says, what is the probability that the next voter to exit will be between 30 to 44? So in this case, our event is going to be the 30 to 44 group range. Okay. So here, we already know that that is currently 8. So the probability that another voter in that range is going to come out is based on the number that have already occurred. Now in this case, we want to then know the total number of times the event occurred or experiment performed, and that is going to be 64. So in this case, my probability of having a voter between 30 to 44 age range is going to be 8 over 64, which is actually going to be 0.125. Okay, and so that's what we're getting at. We are getting at the decimal value of that probability. Now the next part says, what is the probability that the next voter to exit will be either in either of the youngest two age groups? So the first thing we have to do again is identify your event, and that event is going to be 17 to 29 and 30 to 44. And so when we look at what that actual event is going to be, I had 9 people show up in the 17 to 29, and I had 8 people in my 30 to 44. So that gives me a total of 17 members in that group. So here again, the probability that a voter is in either 17 to 29 or 30 to 44 is going to be 17 over 64. Okay, so the number in the group over the number of times my sample has been run. So in this case, we get a probability of 0.265625. Okay, let's look at something that's a little bit different here. Now here we have a sample of 500 active duty military, and in this sample it showed that 82 of them suffered from PTSD, or post-traumatic stress disorder. However, 95 of those studied reported that they would be too embarrassed to seek mental health services. So the first part says, based on the sample, if a soldier is chosen at random, what is the probability that he or she suffers from PTSD? So this is what we know. We know our event is going to be the number that suffer from PTSD. And in this case, we know that there's 82 of those. We also know that the total number of times this event occurred was 500, because we surveyed 500 military personnel. Therefore, the probability that a soldier has PTSD is going to be 82 out of the 500 sampled, which in this case is going to be 0.164 is our probability. Now the second part says, based on the sample, if a soldier is chosen at random, what is the probability that he or she would be willing to seek mental health services? So here we have a new event. And in this case, my event is going to be the number that are willing to seek help. Well, that number is going to be my 500 sampled minus the 95 that said they were too embarrassed. So that is going to give you 405 that are willing to seek help. So in this case, my probability of soldiers willing to seek help is going to be the 405 that are okay with it out of the 500 sampled. So in this case, that probability is 0.81. Okay. So there are 2 examples about calculating an empirical probability. Remember, the difference between empirical and classical is that empirical probability is talking about surveys. It's talking about voters or taking count of an experiment, whereas classical is talking more about decks of cards, dice, games, things like that. So when we're talking about your empirical, just remember you are looking for problems that are related to surveys and things of that nature. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I will see you next time.